Now, last week we looked at stress and strain. Stress being force divided by area, strain being change in length divided by length. Obviously what we had when we had area, we also had to think about the area of a circle or the area of a rectangle for the cross-sectional area of whatever material we were doing, looking at the stress of, okay. Now this week, we're going to combine those two things into a factor called Young's modulus of elasticity, which is stress over strain. And so that we don't have to write that out, we use a capital letter E for that. And the units are kilonewtons per millimetre squared. Now we don't have to calculate that every time something we're given it. And each material has got its own Young's modulus. More about that in a couple of weeks' time. Let's look at one of the calculations you have to do today. So I'm going to get you to do the first half of this paper here, probably questions 1 to 5, and I'm going to do 4 as an example. So I've underlined all the important numbers here. It says a force of 1.5 kilonewtons is applied to the free end of a vertical wire, which is 6 meters long. So that's something hanging from it. The extension that resulted, in other words, it's stretched by 12 millimeters. You're given Young's, which is 196 kilonewtons per millimeter squared, and you have to find the diameter of the wire. Now, when you're doing this sort of thing, it is very much a mathematical trail that you are following. Okay, so there is all the numbers. I've converted some of them from meters to millimeters or kilonewtons to newtons. I've left Young's as kilonewtons just now. So what can we work out? So for definite we have got delta L divided by L, and we could work out the strain. So that's easy enough. Now we have to find the diameter. Eventually we have to find the diameter. So we could start off with Young's is equal to stress over strain, and therefore stress is equal to Young's times strain, and there we go. So we're now able to work out what the stress in that particular material is. Okay. Right. So we also know that stress is force divided by area. So if we've got the stress using Young's and the strain, we can work out what the area is. Area is equal to force divided by stress. We'll keep on moving. And so we've got the force, which is 1.5 kilonewtons, and we've got the stress, which is 392, and we're able to work out the area of the cross section. So now finally reveal our very last part. So we've got area is equal to pi r squared, which means radius is equal to the square root of area divided by pi. And so we're able to then work out the radius. Obviously, with being engineers, don't just leave it as the radius. Work out the diameter by multiplying that by 2, and I've rounded up to 0.7 millimeters. Okay, and that's number 4 done, and number 4 is pretty typical.